Hello, and welcome back to Teacher Gimple channel. Today we're going to be going over Illustrative Math, Geometry, Unit 2, Lesson 4, Practice Problems. If you like this video, please make sure to like and subscribe, and also, if you're a teacher, make sure to check out our new website, rateyourprinciples.org. Let's get started. Problem number 1. Match each statement using only the information shown in the pairs of congruent triangles. So, we're going to match the statements with the pairs of congruent triangles. Let's scroll down a little bit so we can see all of them. A. In the two triangles, there are 3 pairs of congruent sides. So let's go ahead and mark what's congruent in our first pair of triangles. I see 1 pair of sides that is congruent in this triangle. I'm putting an S on each one. I know that because there's 1 dash in each side. Now we have 1 angle that's congruent in each triangle. So congruent means exactly the same measure for our angle. So I'm going to put an angle. Then here we see we have this side with 2 dashes and this side and 2 dashes, which gives us a second side. So these 2 triangles have a side, an angle, and a side in common. Here we're looking for 3 pairs of 2 congruent sides. So let's keep going. Here we have 2 triangles. We got triangle 1, we got triangle 2, even though they're side by side. Now here, this has 1 dash, so that's an angle that is congruent to this angle right there that also has a dash. Down here, we have another angle that's congruent to this angle over there. And if you notice, this side is shared by both triangles. So we know it has to be exactly the same size, so it's congruent. So actually, we count him as a side for both triangles. So here we have an angle, a side, and an angle. But we're still looking for 3 pairs of congruent sides. So let's look to our second pair of triangles here. I'm going to name him, actually, I'm not going to name him A. I'm going to name him triangle 1 and him triangle 2. Triangle 1 has that side that is congruent to this side, so we have 1 pair of sides. We have a second pair of sides right here, so they each get an S. And then finally, we have that same shared side right there that's in both triangle 1 and triangle 2. So he's a third pair of sides. We call this shared side. We know it's congruent, and the term for that we're going to use is the reflexive property. But we have found our 3 congruent sides, so we're matching 3 with A. Now we're looking for the 2 sides and the included angle of one triangle are congruent to the 2 sides and the included angle of another triangle. Well, here we found we had a side, an angle, and a side. The A is in the middle because it's included, so we can match. And then finally, we know C goes with 2, but let's read it anyways. The angle and the included side of one triangle are congruent to the 2 angles and included side of another triangle. Well, here we go. We have the angle, the side in between the angle, which is the included side, and the other angle is congruent to the angle side angle, which is ASA. The side is in the middle of the 2 angles. It's included, so they match. As always, pause this video if you need to go over this question because I'm going on to the next one. Problem number 2. Sketch the unique triangles that can be made with an angle measures 40 and 100 degrees and a side length of 3. How do you know you have sketched all possibilities? Well, let's look. If we have an angle of 100 degrees, and then we make an angle of 40 degrees, we know that all triangles have 180 degrees, so our third side right here, we can quickly calculate. Oops, I put 40. That is not what I meant to do. 180, because we know angle 1, angle 2, and angle 3, which we don't know. So we're putting a question mark, has to equal 180. So we can do a quick math. I'm going to add these guys up. That's a question mark. I'm going to subtract him from both sides. And you might be able to do this in your head, which is fine. This might be obvious to you. So and I know that this missing angle is 40 degrees. This tells me that this right here is an isosceles triangle, so this side and this side are exactly the same. So if this side is 3, then we also know that side is 3. But is that the only option for a side length of 3? Let's see. I'm going to draw that same triangle over again, and we know one angle has to be 100, because that's what we're told. The next angle has to be 40, because that's what we're told. I know that looks like 400. That's 40 degrees. And then we know this third angle, because we solved it out, also has to be 40 degrees. We could also say we know this side is the same as that side, But those two sides don't necessarily have to be the side length of 3. We can actually have the side length of 3 down there. So we actually only have these two options for a triangle, because if the two angles are 40 and 100, the third one also has to be 40. And so if this one, we know it's an isosceles triangle, so if this one's 3, that one's 3. If this one's 3, that one's 3. So that's our one option for a triangle. But also we could say this bottom one is 3, and so then the bottom one is also 3. So this is one option 1 and option 2. Pause this video or actually try to redo it yourself if you still need some help on that question. Problem number 3. What is the least amount of information you need to construct a triangle congruent to this one? Well, we could use an angle, a side, and an angle. We could use a side, angle, side. We could use a side, angle, side, like that. I said side, angle, side. I meant side, side, side. We could use angle, angle, side. We could use any of these. You need 3 pieces of information for every single one. So if you want to say angle, side, angle, that's 3 pieces of information. If you want to say angle, angle, side, still 3 pieces of information. So we need at least 3 pieces of information, and choose one of these to put as your answer. Next question. Problem number 4. Triangle ABC is congruent to triangle EDF. So May knows that there is a sequence of rigid motion that takes ABC to EDF. Remember, rigid motion is one of our 3 transformations: rotation, reflection, or translation. Rigid motion preserves 2 things. It preserves the angle measures, so the angle measures stay the same, and it preserves the lengths of the sides, so the lengths of the sides will stay the same. Rigid motion always produces congruent figures, or figures that are exactly the same, or you can stack on top of each other and they match up perfectly. We're looking for all true statements after the transformation. So we know ABC to EDF. A is going to go on top of E. So A goes on top of E. So imagine this blue triangle slid on over and it went over this way. I know that because A and E match up. C is going to go on top of F, so I'm going to put a C over there, and our B is going to be down there. So imagine that triangle slid and went on top, and that those are our angles are matched up. Does angle A coincide with angle E? Yup. Does angle B coincide with angle F? Nope. Does AB coincide with EF? Well, AB is right here, and EF is right there. Nope. Segment BC coincides with DF. BC goes up here, DF goes up there. Yup. And segment AC coincides with segment ED. AC is here, ED is there. That's it. Nope. And we're done. This is a method I haven't shown in other videos, but if you like it, I highly recommend that you use it, because lots of methods are possible, and that one is clear. If you still had a hard time, make sure to pull out some tracing paper and try that question on your own. Problem number 5. A rotation by angle ACE using point C as the center takes triangle CBA onto triangle CDE. So CBA is going on top of CDE. I'm going to use the same method I used last time. So when we slide them over, A is going to end up over here, and B is going to end up over there, and then C ends up actually in the same spot. Explain why the image of segment CB lines up with the axis, lines up with segment CD. So why does CB line up with CD? Well, because it is a rotation, the side lengths stay the same, and the one triangle lined up and went smack on top of the other triangle, so they are going to be exactly the same, lined up perfectly, and the same length. Explain why the image of B coincides with D. Well, B rotates all the way by the same measure to line up with B, or the geometric term we're going to be using is it corresponds. So B corresponds with D because the rotation brought the B smack on top of D. Finally, is triangle ABC congruent to triangle EDC? It's a rotation. Let's double check that our letters are in order. ABC, EDC. Yep, our letters are corresponding. It's a rotation. Rotation is rigid motion. Rigid motion means congruent. All right, let's go on to the next question. Problem number 6. Line EF is a line of symmetry for figure ABECDF. So it's that whole figure. Claire says that ABEF is congruent to C, D, F, E besides A, B, and C, D correspond? Why is Claire's congruent statement incorrect? Write a congruent statement for the quadrilaterals. So we had A, B, E, F. So A lines up with D, kind of imagine it folded over because there's a line of symmetry, which is the same as a reflection. B matches up with C, and then the E and F are stacked on top of each other. So we have, Claire says A, B, E, F should line up with C, D, F, E. Okay, gotta do this a different way because there's way too many letters there. So we have, Claire says A, B, E, F line up with C, D. Okay, so A, B lines up with C, D. We're good with that. F, E, C, D. And then he went over here, F, E. So AB lines up with DC. Yep, they're corresponding. But then FD does not line up with BE. We would need to go this way. So that's why it is incorrect. It is not corresponding. So if we wanted to say ABEF is congruent, well, AB is like DC, BE is like CE, so CE, and then EF is EF. And that would be our correct congruency statement. So use your visualizations, use your tracing paper, watch this question again if you need to have any questions, and we're going on to the next one. Problem number 7. Triangle, HEF is the image of triangle HGF after a reflection across line FH. So HEF is the image, so we're reflecting. Select all statements that must be true. So G is going to match up to E, and then F and H actually stay in the same spot. Triangle FGH is congruent to triangle FEH. FGH is congruent to FEH. Yep, those correspond. We're good to go. Triangle EFH is congruent to triangle GFH. Those correspond. We're good to go. Angle HFE is congruent to triangle FHG. Those do not correspond. We are not good to go. Angle EFG is congruent to angle EHG. What? No, we are not good to go. Now we have segment EH is congruent to segment FG. EH is right here. Is he congruent to FG? No. So, not correct. Let's erase those so it's not confusing. And then segment GH. GH, is he congruent to segment EH? Or do they correspond? Yep. All right. So, you should be an expert at corresponding angles right now. But if you need extra practice, pause this video and try one of those questions on your own. Problem number 8. When rectangle ABCD is reflected across line EF, so we have rectangle ABCD is reflected over EF, so it's kind of flipped over. We have an image which is BADC. How do you know that segment AD is congruent to BC? Well, when we reflect this over, it kind of like flips completely, and it lines up perfectly. Because the image of this rectangle is the same as the image of that rectangle. So AD actually corresponds to BC, which makes them congruent. So we're looking for the corresponding answer. Now, they keep on giving these two answers. Remember, it's corresponding parts of congruent figures are congruent, not congruent parts of congruent figures are congruent. AD corresponds to BC, therefore, they are congruent. Because ABCD is congruent to BADC because it is a reflection. A reflection is rigid motion. Rigid motion means the figures are congruent. All right, let's go on to the next question. Problem number 9. The design began from the construction of a regular hexagon. Describe a rigid motion that will take the figure onto itself. I'm going to use a cheat method. It's my favorite one. We're going to make a point smack in the middle. Rotate him 360 degrees any direction, and he's going to line up. So a rotation of 360 degrees. That's literally spin all the way around back on itself. But the truth is, I actually think a rotation of 180 degrees will do the same thing. Because when you rotate around 180 degrees, this triangle is going to end up on that triangle. This line is going to end up on that line. We know that all these sides are congruent because it is a regular hexagon. A regular hexagon means all the sides are the same. And I think that is correct. Now, do we know that this side is congruent to that angle right there? Not necessarily. So this guy is a for sure option. And this guy, I'm going to go, is a mostly for sure option, but we don't actually know that they're perfectly congruent, so he's the best option right here. If you have any questions, put them in the comments below. As always, like this video, subscribe, and I will see you in the next one.